Welcome to our talk on supercharging observability at OpsVerse using ClickHouse real-time analytics. My name is Robert Hodges, and it's my pleasure today to be presenting with Arul Jegadish. Just a couple of housekeeping things for our presentation. You don't need to scribble notes because we will be recording this webinar. It's being recorded right now, and we'll send you a link to the recording as well as the slides after the webinar is complete. Second thing, we do have time for questions. You can enter them into the Q&A box, which is included as part of the Zoom control bar. You can also just put them into the chat. If they're relevant to what we're talking about on a particular screen, we may just answer them then and there. Otherwise, we will have time to answer them at the end. So with that, let's go ahead and dive in. So my name is, once again, is Robert Hodges. I've been working on databases for over 40 years, most recently on ClickHouse. And my day job is I'm CEO of Altinity. Arul, would you like to go ahead and introduce yourself?
Sure. Hello, everyone. I'm Arul Jegadish. I'm one of the co-founders of OpsVerse. I have more than 20 years of experience in DevOps and developer tools domain. I'm a great believer in open source, in using open standards and open source based tools for DevOps. And that's something that we embedded into the founding story of OpsVerse. And with OpsVerse, we make it easy for anyone out there to consume DevOps tools. And Robert, thanks a lot for inviting me to this webinar. I mean, I'm a great fan of the Altinity webinar series. I'm really excited to be here today to share some of our experiences using ClickHouse at OpsVerse.
Great. Same here. So thank you so much for joining. Let me do one little housekeeping thing. I'm going to try and get this screen there we go. Okay, the screen is now no longer showing the menu bar. Let's, Arul, since you're talking, why don't you just introduce OpsVerse and what they do?
Sure. So OpsVerse provides a DevOps tools platform. And with OpsVerse, you can get OSS-based DevOps tools running in minutes and on any cloud, including within your own cloud account. We are talking about tools like observability tools, CI/CD tools, developer portals, product analytics tools. You will be able to get these tools up and running wherever you want within minutes with OpsVerse.
Great. And at Altinity, we're an enterprise provider for ClickHouse. So we've been in the market for over 5 years. Includes some of the folks on our team were the earliest users of ClickHouse in North America, as well as other locations. We run a cloud platform for ClickHouse called Altinity.cloud. It was the first ClickHouse platform that appeared on Amazon as well as GCP. And we basically help people build real-time analytic applications in the cloud, on Kubernetes, and on-prem. And just to echo something that Arul said, we are really, really big fans of open source. This is fundamental to what we do. ClickHouse itself is open sourced, of course, and then there's a whole ecosystem of tools and that go around it that enable people to build very high performance analytics, but not have to worry about lock-in, to be able to understand fully how the stack works, so on and so forth. So with that, I'd like to turn it over to Arul to talk a little bit about the observability problem and what OpsVerse is, how OpsVerse is attacking it.
Sure. Thanks, Robert. Yeah. So in the first section, we'll talk about the problems that we faced and how we solved it by switching to ClickHouse. So Robert, if we can move on to the next slide. Yeah, so I would like to introduce like one of the tools. Like when I talked about OpsVerse, I mentioned that we run a DevOps tools platform. One of the tools that we run on the platform is a full stack observability solution. Now, this is a solution where we bring in metrics, logs, traces, and profiling under one platform, under one umbrella. And this is a tool stack that you can come to our website, click, and then run on any region, any cloud. You can run it as SaaS or as private SaaS, meaning as private SaaS, this entire stack gets fully managed within your own cloud account or within your own network. Um, now, yeah, Robert, if you can go to the next slide. So now in this tag, there is one of the subcomponents is the distributed traces component, where we use OpenTelemetry to instrument and collect traces. And then we use Aegir in the backend to process it and store those traces. Now, to begin with, we were using Cassandra as the backend store for Aegir's data. And then we switched to ClickHouse. So today, like that's going to be the main topic here. That's what we are going to talk about here on why we switched and what benefits we got when we switched to ClickHouse. If we can go to the next slide. Yeah, so before we started using ClickHouse, some of the common problems we had were Aegir was using Cassandra as the data store. So we didn't really have any analytical capabilities on top of that data. So Aegir would dump the data into Cassandra, and we could make use of the Aegir UI and Aegir API, and that was pretty much it. We were not able to get anything else out of that data. Plus, running and managing Cassandra beyond a basic scale was also a little problematic with respect to the operational overhead, as well as with respect to the cloud resource cost. So at that time, we started looking at other options, and we found ClickHouse. And if you can go to the next slide. Yeah, so and after we switched ClickHouse, basically what we did was we got Aegir to dump all the data it received into ClickHouse. Now, out of the box, we gained a lot of analytical capabilities. We were able to extract a lot of insights from this data from Aegir. So we built a new APM module on top of ClickHouse. This itself is a great takeaway here. So if you are using OpenTelemetry to instrument your applications and to generate spans and traces, just by storing all those traces in ClickHouse, you can actually gain a lot of insights. You can generate a lot of insights from that data. And then what we did was we connected the ClickHouse DB to Grafana through a ClickHouse data source. And then we were able to build out our full-fledged APM with that. Plus, we were also able to now generate alerts on top of the tracing data. And as a bonus, our infrastructure costs also went down because ClickHouse has really good compression. Plus, the overall management overhead also went down. So that's at a high level. That's the switch that we did. Now, in the second part of the webinar, we'll actually go into the details of our implementation as well. I have one more slide here to talk about how we use Kubernetes. Today in this webinar, we'll be talking about Kubernetes a lot. So here is a quick overview about how at OpsVerse we run our platform. So what we do is, again, at the top is basically all the awesome DevOps tools that we run and orchestrate for our customers. Now, at the way we are cloud agnostic. So at the bottom, you have Terraform. We have a very thin layer of Terraform, and we use Terraform to create Kubernetes instances in any of the public cloud instances. And these are standard managed Kubernetes instances like EKS, GKE, and AKS. And we do the same thing within customer cloud for our private SaaS as well. So our usage of Terraform is like very thin. We bring, and the purpose of Terraform here is to create the Kubernetes clusters. And once we create Kubernetes, everything's Kubernetes native. I won't even call it cloud native at this point. Everything's Kubernetes native. And we use Argo CD a lot to manage the delivery of different resources to these Kubernetes clusters running across different public cloud infrastructure. And when we talk about the kind of Kubernetes resources, of course, there are these core Kubernetes resources like deployment, stateful set, ingress rules, etc. And then we make use of a lot of Kubernetes custom resources and operators. And that's where we use Altinity's operator to run ClickHouse, for example. Um, and then we also use Crossplane to create any additional cloud resources. Once we create Kubernetes, then if you need to, for example, provision a S3 bucket or a GCS bucket, or if you want to make like Route 53 entries, these are resources that live outside Kubernetes. So we use Crossplane as the bridge between the Kubernetes API and the outside world and the rest of the cloud. So that's our at a high level, that's how we run our platform. And the way ClickHouse fits in is through the Altinity operator. And the second part of the webinar, we'll actually go into some of the implementation details. Over to you, Robert.
Thank you, Arul. So what I'm going to do now is give a quick intro to ClickHouse and then also talk a little bit about ClickHouse on Kubernetes. So let's first dive in. I think many people on this call already know about ClickHouse as an analytic database, but in case you don't, let me just give you a brief summary of what ClickHouse is. So ClickHouse is what we call a real-time analytic database. We sometimes call it a data warehouse, but that's a bit of a loose term. The point with ClickHouse is that it's particularly well suited to support applications that have large amounts of data rapidly arriving, and that data is being presented to end users, often with very high performance requirements. So for example, the ability to bring up an operational dashboard and have it appear in a second, or to be able to do a query on the database and be able to answer a question, say within 10 milliseconds, so that you can actually add something to a page as it's rendering. So this is what we mean by a real-time analytic database. So ClickHouse, when we look down its properties, first of all, it understands SQL. It uses a dialect kind of similar to MySQL. And like MySQL, it runs pretty much everywhere. You can literally run it on a phone. We just did a talk last week on running it on Raspberry Pis. It's open source. Jumping down to the bottom, again, very similar to MySQL, and it uses the Apache 2.0 license, which is very flexible. It means you can use it virtually anywhere you want without encumbrances. Moving to the actual analytic capabilities, first of all, ClickHouse was designed originally to use what's called a shared nothing architecture, which means you have a bunch of nodes, they have attached storage, or shall we say, patches of storage that they own, and then they connect over a network. This is a very straightforward architecture, has a lot of strengths. It doesn't require special network configuration, is very flexible about types of storage it can use. Second thing is we store the data in columns. Virtually all respectable analytic databases do this. This means that we can store enormous amounts of data, but when we do a select, we only have to read the data for the columns that we're interested in. Moreover, by using columnar format, it enables enormous compression. We can get compression rates greater than 90% or 99% in some cases, and I'll show you an example of that in a minute. As far as using that, sort of applying, running queries on that data, you've minimized the amount that you actually have to read thanks to compression and thanks to the fact that it's in columns, and then you apply as much compute as you can to make the remainder run as quickly as possible. So ClickHouse does what's called vectorized query execution, where it basically treats the columns as arrays, which then get loaded onto the processor. We can use single instruction multiple data instructions. We're also well aligned with cache boundaries inside the CPU. So we get very high and efficient utilization of cores in the processor. Plus, we can run parallel across many nodes. And then finally, the ClickHouse clusters can scale to enormous levels. Tens of petabytes are not uncommon. One of our customers that I work with regularly runs about 387 nodes in their main cluster. And as a result of these capabilities and others, ClickHouse has become very popular as this engine for real-time analytics, particularly for SaaS businesses like OpsVerse. So reading from event streams, from ELT products like RudderStack, being able to read from object storage, and then to expose the data to consumers in a variety of different ways. So what does it do to run so fast? Well, the short answer is practically everything. If there's a way to make a database run fast, there's a good chance ClickHouse does it somewhere. So these include everything from codecs, which are transformations on data, to distributed query, to efficient sort of indexes that are designed to fit in memory. You can see all these different types of features here. What I would actually like to do is, because there's such a wealth of things that you can do with ClickHouse, I'd just like to focus on a very small part of ClickHouse and show you how we can actually go about loading data for a use case like OpsVerse, where we're dealing with observability information. So let's dig into that. So the first thing is I want to show you a typical table in ClickHouse that just illustrate some of the visible features that you get with this columnar storage with high compression. So for example, this is a table definition right here. It looks kind of like SQL. ClickHouse has its own types for the columns. It can actually use the ASCII columns, but most people use the native types. And I just want to highlight a few features here. So for example, we have this sensor ID. This is, by the way, test data for temperature readings on sensors. And it has this thing called codec. And what that's doing is saying, hey, don't just compress this column, but in fact, apply a transformation on it called double delta, which means that as we walk down the column, we don't store the sensor ID values, but instead we store the change on the change in the sensor ID values. And it happens we sort them so that we're going to be an ascending sensor ID value. What this does is it basically makes the amount of data required for this column almost vanishingly small. And then once the transformation has been applied and we have some string of bits, we turn it over to LZ4 compression. Other examples, we can create what are called alias columns, which are just appear to be columns in your query, but in fact, they're just computed off available data. Like in this case, the date column just does a transformation on the time column to turn it into a date. We have optimized data types like enum. That's an 8-bit column to store this message type column. And then very important features down at the bottom are partitioning and ordering. These are critical in large analytic systems. So what partitioning does is it breaks the table up into pieces, which are then establish a grouping of the data that can be used, first of all, to allow efficient access. And they also are sort of a management unit. And in this case, what we're doing is partitioning by month. So we'll have bins of data. And then, for example, if we decide, hey, we're keeping 12 months of data, at the end in the 13th month, we can just go ahead and then drop the partitions or drop the partition for the first month. So that's a really important way of organizing data. And you'll notice it's done by time, which is very common. And then the second thing is ordering. So we have to sort the data within each column so that the columns then match and we can find particular rows. And in this case, we'll do something where we'll sort by the type of message that we're storing, the sensor ID, and the time. So what you do is you end up getting contiguous stretches of storage devoted, for example, to particular sensors. This helps compression work better. It helps things like codecs work better, and it just results in very, very fast scans. So that's the basic table organization. Let's look at how we get data in. So it's really common to read data in from JSON. So here's an example. If we took out the carriage returns here and just had this on a single line and had a bunch of lines with the same sorts of JSON documents, this is a format that we call JSON each row. And it turns out that this type of JSON could be read into ClickHouse very, very easily. Here's an example. So I have that readings table that I created, and I'm just going to say, hey, insert into readings, and I give the columns that I'm inserting into, and then I have this expression at the end, format JSON each row. and that just says, hey, instead of having like an insert with a values clause, I'm just going to be reading a bunch of JSON data. And then what you can do is you can just pipe this input data into ClickHouse client, which is the standard client. There's other ways to do this, but it will basically suck this JSON data in, parse it, and then automatically assign it to the each row to the appropriate columns. So this is incredibly simple to load data in. Now, one of the things this does require is that you know in advance what columns uh, you have, but in some cases, we might want to uh, use a trick in ClickHouse, which is that we're actually going to keep the source data, and you can see that on the right side. And then what we'll do is, so we actually have these little JSON objects that have been loaded, which could actually be big. In some cases, they may contain, dozens or even hundreds of items. We keep those in ClickHouse in a column, and then what we'll do is we'll materialize uh, some of those values out into proper table columns. So this is a very common way of handling data. In this particular test data that we're using, because of compression, uh, the amount of information that we store per row is extremely low. So for example, here this was data taken across a trillion row data set. On average, we were storing 1.34 bytes per row. This is really small. And then that JSON document, which is pretty voluminous, actually only takes 4 bytes. And the reason for that is there's a lot of repetition, and we can apply ZSTD compression to it and make it really small. So let me just show an example of how that actually works. So what we're going to do is we'll create a slightly different table definition. And in this particular case, we'll still have the same original columns, but down at the bottom, you'll see there's a JSON value, which is a string. And actually, the way I've defined it here, it won't use ZSTD. It'll actually use LZ4. That's the default. But if you look back up at the sensor ID, you can see that it has this new clause which says materialized, and then it's going to use what's called a JSON value function to pull the data value out of the JSON string. And so what this does is when we actually load the data, we can just load the JSON string, and then ClickHouse will automatically fill in the remaining columns with these values. So there's another way that you can do this. If if you've manipulated JSON before, you can also use the word default instead of materialized. The distinction between them is if you say materialized, when you do a select star, the column will not appear. If you say default, it will appear. So it's your choice. But very simple way to pull the data out. And in fact, when we want to read the data, this is what it looks like. We'll just say insert into, I've created a different table because it has a different format. I'm just going to read that one JSON column, and I'm going to fool ClickHouse into thinking, hey, this is actually just data for a single column, not something that should be mapped across to multiple format columns. So I'll read it as tab separated values. Again, I pipe it in, and bang, it populates my table. So this is a simple way of both preserving the original JSON in case I'd like to pull out additional values later, and also getting it populated into columns for query. There's more we can do here. So a really important feature in ClickHouse is materialized views. And they basically take data from a source table, and every time you load a block of data by doing an insert, they'll fire a trigger automatically. And this trigger is driven by this materialized view. I have one called readings convert. And what it's going to do is run a query over that data and put the results into another table. So this can be used for a bunch of things. We commonly use it to pre-aggregate data, but one of the fundamental ideas is just transforming input data as it appears in ClickHouse. So here's the source table definition. So we're just going to have a very simple table which just contains that JSON string. And we're going to use a special engine here called null. And what that means is we're actually not going to store any data here. That this table simply exists as a place to receive input. And what we're going to do is then transform that input and stick it into the real table. So the real table looks like this. It's pretty much our table definition that we had that I first showed you. And it has all the usual columns, and then it just has JSON string. So, so that's the target that we're aiming at. Let's see how we get there. We have the materialized view, which is the that we create, which is going to go ahead and actually, every time something is put into that input table, it will run this select that you can see here. It will pull the data out and put the results automatically into the target table, which is readings converted. So this is a very powerful feature, very commonly used transformation. When people are loading data, you can almost think of this as kind of like constructing a mini pipeline for within ClickHouse itself. There's one other cool feature about this that I think is worth describing, which is as you're adding this data in, you can actually join on other tables as well. So it's not just we're not just reading the input data and performing transformations on only those columns. We can then join with other tables and pull that data in as well. So here's a really simple example of how we might modify that materialized view. And here what I'm going to do is I have a sensor type. And what I'd like to do is pull the name of the sensor as well as its description. Those are strings that I can then use in output. I'll add them to the table so that those columns exist. And then I'll change the materialized view so that I actually have a join included in that select query. So if you're familiar with join syntax, this is completely standard. There's nothing special here. But what this does is allows you to pull in additional data. One thing that's important to understand is that as this is, because this is a trigger, it only triggers when you add data to the left side table. If you change the other tables that are in the join, you won't have data added into the target table. So a little bit of behavior that it's useful to understand. So that's just a taste of the flexibility. Here's the result when we do this join. The data actually is pulled in, and you can see how it joined this data in. There are many other things you can do with ClickHouse, but what I'd like to do now is switch over and talk a little bit about cloud native ClickHouse. So because this is the environment that OpsVerse is using, it's an increasingly popular way to run ClickHouse databases. So for those of you not familiar with Kubernetes, it's an orchestrator for container-based apps. And what it does is it has a resource model, which is designed to describe distributed systems. It includes things like pods, which turn out to map to containers, which are, of course, a process running somewhere on a host. It has things like volume claims, which says, hey, my pod needs a certain amount of storage. There's actually the implementation of the storage. That's a persistent volume, which may map through to a patch of storage on Amazon Elastic Block Storage. So that's the model and how it maps through to the physical infrastructure. The problem is that these, as you can probably understand, that resource model is complex, mostly because it's a lot of little pieces. And when you get to a database like ClickHouse, let's say you have several nodes, it could take dozens of Kubernetes resources to actually represent this ClickHouse properly inside Kubernetes and make sure that it's distributed across availability zones and set up shards and replicas, talk to zookeepers, so on and so forth. So the way that Kubernetes solves this problem is rather than making you define and manage all those resources yourself, to create something like this, what we actually do is introduce a concept called an operator. And so the idea is that an operator defines a new kind of resource, and that resource does handle some custom application. In this case, ClickHouse, and we call the definition of the application a custom resource definition. And you basically fill it out in a YAML file, just like any other resource in Kubernetes. There's a command called kubectl, which you can use to apply it. And what will happen is that resource definition will get read into Kubernetes. The Kubernetes will go ahead and say, okay, I recognize the type of resource you're talking about. I'm going to hand it over to an operator, in this case, the Altinity ClickHouse operator, and it's going to look at the resource definition. It's going to look at what resources are allocated outside, in Kubernetes, and then it'll basically adjust reality. So if a resource like a pod doesn't exist, it will create it. If storage needs to be allocated, it will create it. If the storage is there but a different size, it will arrange to have it be changed to a larger size. And the result is that just by reading a relatively simple file describing your ClickHouse cluster, you'll get a full deployment of the ClickHouse cluster out in Kubernetes in some namespace. So one final thing, here's a little bit of a flavor of what this CRD looks like. This is not the complete CRD, but it would actually take up about 2 slides total to include the pod definitions as well as the storage. But it basically has very simple ways of laying out information like number of shards, number of replicas, where's Zookeeper, so on and so forth. So with this, using this operator, it's relatively simple to set up complex clusters inside Kubernetes, and then to be able to not only run them, but then to make changes to them, extend storage, add or remove replicas, change the ClickHouse version. All of this stuff can be taken care of simply by making changes to the resource definition, this one right here, and then resubmitting it to Kubernetes, and the operator will make the changes for you. So with that, we're at the end of the introduction to ClickHouse. And Arul, I'm going to go ahead and stop my share and let you take over because you're going to do a demo, as well as going deeper to this.
One moment.
I'll let you know when I can see your screen.
Yeah.
I see your screen.
Okay, great. Yeah, so thanks, Robert, for talking about some foundational concepts here. Interestingly, a lot of those concepts that Robert mentioned, we use it in order to implement our APM backend in our observability stack. So just a quick recap of our observability stack. I mean, the OpsVerse Observe Now stack brings together metrics, logs, traces, and profiling data together. We are talking about how we handle OpenTelemetry based traces using ClickHouse. And as Robert mentioned, what we do is we have an ingestion pipeline where data comes in, and we'll look at how we transform that data in a way which is easier for us to query later. Again, we get this data primarily in a JSON format, and then we use materialized columns and materialized views in order to transform that data. So let's, and quickly about this whole data pipeline. So let's, your applications, you would instrument your applications with OpenTelemetry SDK, and that'll make your applications to emit spans and traces, the OpenTelemetry traces. Those are usually collected using OpenTelemetry collector or one of the other collectors out there, but usually OpenTelemetry collector is commonly used. And the OpenTelemetry collector sends those traces to Aegir in the backend. Aegir is run as part of the OpsVerse Observe Now cloud service. And Aegir dumps that data into ClickHouse, and users will finally access that data through Grafana. And through Grafana, either as dashboards or our users can actually run ad hoc queries also through Grafana and access this data here. That's the data pipeline. And with respect to our implementation, now we need to bring in a ClickHouse installation in our Kubernetes environments. So we picked the Altinity operator. Robert talked about the operator. So for us, in order to create a ClickHouse, a production-ready ClickHouse cluster, all we have to do is define that custom resource, which is picked up by the Altinity operator, and the operator does the rest of the magic of provisioning the required pods, provisioning the storage, setting up the config map, setting up a load balancer, setting up our ingress rules, etc. And you get a production ready ClickHouse cluster, ClickHouse installation. And then, as I mentioned earlier, we push this custom resource file to different Kubernetes cluster and different environments through Argo CD. And within Ager, now that we have the ClickHouse, now Ager needs to connect to this ClickHouse and write data to ClickHouse. We use Ager's plugin for ClickHouse in order to make that happen. That's how we switch from Cassandra to ClickHouse. And then, as I mentioned earlier, like we use a lot of materialized columns and materialized views in order to transform that data and load it into new tables. And from there, we use Grafana for both visualization and alerting. At a high level, that's how we have done the implementation. Now let's talk a little bit more about the details. Now, when Ager dumps data to ClickHouse, it's a very simple table. It actually puts in a timestamp, the trace ID, and then model. I mean, model is really a JSON representation of the span, and it has all the information collected through this OpenTelemetry pipeline. Ager also creates a couple of more tables, but this is the most interesting table. What we do is now we make some changes here, and we add some materialized columns here. This is again what Robert mentioned about materialized columns. What we do is we take this model. So as new data is inserted into this table, these materialized columns also get populated, and we basically pull out different fields from this JSON string and then create them as first class columns. So now we can write different queries on top of these columns. So that's one thing that we do. Another thing that we do is, again, there are multiple tables in Ager where we do this. So pieces of information is split between different tables. Now, when we query, we have to create a join. And in order to avoid running the join, like every time we run a query, we create a materialized view that actually finally transforms the data into a table like this. And from here, now we can create all our dashboards very easily. And that's like, this is the base for our APM module. And we finally create our APM dashboards and alerts on top of a table like this. And then here is an example. If you want to now find out all the spans with like HTTP errors in it, then you can now go execute a query like this. Very simple, straightforward query. But then we had to do some data transformation in order to like get to this point. And we were able to do all of that within ClickHouse itself. Now, we didn't have to bring in another ETL system to now process all this data. Everything, this whole data processing is done within ClickHouse. Another thing, in this initial version, we didn't have to touch Ager's code at all. We just have to reconfigure Ager to dump all that data to ClickHouse, and we were able to do all the data processing and then querying within ClickHouse itself. So that way, like switching to ClickHouse really helped us in implementing our new APM module. I'll switch context here and show a very quick demo, and then we can wrap up and take questions. Okay, so I hope you can see my browser here. So this is the OpsVerse admin console. Like if you sign up for a new account in OpsVerse, this is what you will see. And here, over here, like again, we run a DevOps tools platform. So you can come and select the tool that you need, and then you can like launch it and run with it. I'm gonna focus on the observability stack because that's where ClickHouse comes into the picture. So you go into the Observe Now product. You can actually click launch and select where you want to launch, give it a name and launch. And within minutes, you will have a full-fledged, full-stack observability solution. In this case, I already have an observability stack up and running. And if you go here, you will see the different observability sub-modules launched here. I'm gonna switch to Grafana. I'm gonna go inside Grafana. We use Grafana for visualizing all the telemetry data collected. And in Grafana, we have out-of-the-box dashboards, and you can also explore the different telemetry signals that come in. Now I'm going to switch to like the APM module. So this is basically the final result of everything that we have seen so far, where data comes in from your applications through the OpenTelemetry pipeline, reaches ClickHouse, where we transform the data, and then we are able to build APM level insights here by connecting Grafana to the ClickHouse data source. And here, yeah, I mean, you get all type of insights into your application, on how your application is performing, how many requests are coming in, what's the request latency, what's the error rate, and you also get information about the kind of like SQL queries your applications are running, all by just instrumenting OpenTelemetry, or bringing OpenTelemetry into your application. Now these are like some canned dashboards, but then as a end user, you can build your own dashboards, or you can also like select the ClickHouse data source, and you can go create your own queries, ad hoc queries as well over here. So that way you have a lot of flexibility, and you can go into alerting, and if you want, you can actually create your own alerts on top of the data that is in ClickHouse. So if you want to get alerted when your application latency is bad, you'll be able to easily do that. All right, so that's the demo. Here, let me switch back to the slides, and we can wrap up. Robert, go ahead.
You bet. So, in addition to sort of exposing the general problem space that OpsVerse was in, we did talk about ClickHouse, which, as I mentioned, is a real-time analytic database. So this again is a database that's designed to answer questions very quickly on rapidly arriving data, often millions of rows per second, running into tens of petabytes in some cases, and also be able to answer those questions in a timely fashion. So within a second, the kind of dashboards that you just saw from Arul illustrate that perfectly. One of the things about ClickHouse is it runs very well on Kubernetes, and that's kind of the base infrastructure that many people are using today. Our Kubernetes operator has been around for years. We run our own cloud service on it. We have hundreds of ClickHouse clusters running it, and as far as we can tell, there are thousands or even tens of thousands of clusters worldwide using it. So it's heavily tested. You can try it out on Minikube. It takes about probably 30 minutes end to end to get something up and running from scratch on a laptop, including installation of Minikube. And but actually, for production environment, most people use managed Kubernetes services like Amazon EKS, and that we use those ourselves and have had really good experience with them.
Yeah, and from our perspective, I mean, we also talked about how by switching to ClickHouse, we are able to build out a full-fledged APM solution on top of the OpenTelemetry data. So if you are already using like OpenTelemetry in some form, this is something that you could actually make use of. Just dump that data to ClickHouse, and you and your developers will be able to derive a lot of insights out of that. And if you're not at using OpenTelemetry, that's something that you should definitely think about. Consider using OpenTelemetry. You'll gain a lot of application performance related insights. And then if you're like looking for a full-fledged full stack observability solution, there are services like the OpsVerse DevOps tools platform. All right. Um, Go ahead, Robert. I think that's basically all the information that we have for the webinar.
Yep.
Maybe we're ready to take
Lots
some
lots of
questions.
places to find out the OpsVerse blog, OpsVerse website, and then we provide a bunch of different uh, things that can help you get going. There's obviously I left it out by accident. There's obviously the ClickHouse .com site with the reference documentation for ClickHouse is a very powerful resource. Webinars like this are also on the Altinity YouTube channel, as well as these other types of references. So there's lots of information out there, and you can always contact us on Slack, and we'll help you if you're trying things out. So with that, I think we're done. Please do contact us. The contact information for us is shown here. Once again, my name is Robert Hodges, and talking today with Arul. Please do come visit us. Use OpsVerse for your monitoring. Altinity, we can help you run ClickHouse anywhere you need to run it. So, and we've been doing it for many years and are happy to help. So, with that, Rule, if you don't mind, just like to ask you a couple of questions. Can you talk a little bit about the migration that you went through? Did you actually have to move data from Cassandra over to ClickHouse? And if so, how did you do that?
So we did migrate the data, and in this case, we actually because the data is not very complex, as you saw, we really had to bring in this one table over from sort of Cassandra into ClickHouse, and then the ClickHouse pipeline took care of massaging the data. So in our case, we wrote a custom migration script to migrate the data from Cassandra to ClickHouse. And this is all time series data. So it was pretty easy for us to do it in batches and migrate the data over.
Great. And I think you showed Azure as one of the environments that you're supporting for
Yeah,
Kubernetes. Did I see that correctly?
that's correct. Basically, the whole platform is cloud agnostic. Let me get to that. Um, it's cloud agnostic. The whole platform can run wherever you have a Kubernetes cluster. So we already have the DevOps tools platform, the OpsVerse tools platform running on all three major clouds, including within customers' own cloud accounts.
Yeah, I wonder if you have any comments, like particularly looking at the public clouds like Oz versus GCP versus Azure. Did you notice any differences between their Kubernetes implementation, and were there any particular things that you had to do to
Um,
to adapt to platforms?
Yeah, so not really, and I think that's the key point here, right? I mean, there's not a lot of difference with Kubernetes. The managed Kubernetes offered by the EKS and GKE and Azure, which is AKS. Yeah, I mean, there is some differences when you bring up and install Kubernetes itself, but then once you have Kubernetes up and running, the differences are like pretty minimal. And that's the most important thing here. So if you truly develop your applications and tools to be Kubernetes native in a way, then you can definitely think about bringing in cloud agnostic features to your application, as well as you can make your applications multi-cloud.
Yeah, that is very consistent with our experience on Kubernetes. So when we built our cloud, um, we started out on Amazon. That was in October of 2020, and then about a year later, or 9 months later, we decided, okay, we want to bring GCP on, and it took us 8 weeks end to end to port the cloud from from Amazon to GCP, and it was mostly deciding, like how to get as you say, how to get the clusters set up
Yep.
within the Kubernetes itself. Pretty much everything ran, and that the places where we do see differences are things like external connectivity, like what kind of load balancer you set up to
Yep.
get in off the internet, if that's what you're doing. But the by and large within Kubernetes itself, things just run. And in fact, that even applies if you can develop something on Minikube, which is the developer version of Kubernetes, and the CRD will pretty much run anywhere. You can run it in EKS. So that's
Yeah.
I think the portability story on Kubernetes is really good.
Yeah, yeah. And I also want to highlight like our usage of crossplane. So, I mean, once you are in the Kubernetes world, once you get into Kubernetes, now if you need to as part of your Kubernetes operations, if you need to bring in any other non-Kubernetes cloud resources, then crossplane is a great way to connect your Kubernetes to the rest of the world. For example, today when a user comes to our admin console and launches an observability stack, we need to provision like S3 buckets or a GCS bucket. And we also need to make like Route 53 entries. So in those cases, we don't have to, we can still operate within the Kubernetes context. And making a Route 53 entry is just another custom resource that we have to push to that Kubernetes cluster, and crossplane connector takes care of making that connection to the AWS resource. So that's another great way to ensure you are able to ensure that you can build within the Kubernetes context.
Great. Yeah, this has been really great hearing about your experience both with ClickHouse as well as Kubernetes. And one final question: when you came in on Kubernetes, did you and your team have background in Kubernetes already, or was it something you started when you founded OpsVerse?
We already had some experience running production grade applications on Kubernetes, but specifically like running data, like bringing databases and basically data on Kubernetes was something that we started on only at OpsVerse. And that was, I think in general in the industry, um, adoption of data on Kubernetes is still low. Somehow there is this assumption that you can't run like big databases on Kubernetes. But we like that's something we did it in OpsVerse. We run ClickHouse. We run a few other data stores as well. We run Postgres. We run a few more data sources, databases on Kubernetes at scale. At scale, multi-cloud, we are able to run it on like different cloud environments, and we are able to handle a lot of data within Kubernetes itself.
Great. Well, since you mentioned data on Kubernetes, I just want to put in a quick plug for those of you interested in the subject. There is actually a whole organization called DOK, or Data on Kubernetes. It's worldwide, devoted to promoting people running databases on Kubernetes, just as you've heard here. We are starting a new meetup for data on Kubernetes in the Bay Area. For those of you that are in the San Francisco, San Jose vicinity, and our first meetup will be in May. So watch out for that, and definitely check out DOK. Arul, this is something where I think a lot of the folks that I know in DOK would definitely be interested in your experiences as well.
Yeah,
So
yeah,
perhaps you
yeah.
guys can come and do a talk there.
Definitely. I really look forward to that.
Great. Thanks. I don't see any further questions, so I'm good. I think we'll call it a day. Arul, thank you again. Thank you everybody for attending. It's been a pleasure, and we'll send out the links both to the slides as well as to the video within a day or two of of the completion of the webinar. So thank you and have a great day.
Yeah. Thank you. Thanks everyone. Thanks, Robert.
All right. Bye bye. See you later.
Bye.